Hey guys, let's discuss new design today, or let's design new system in system design today, which is called AI-powered advertisement ranking or advertisement servicing system. So, like we have Google Ads or Meta, so similar to that, we need to design our system. So here the problem statement is design a system that serves advertisements in less than 100 millisecond latency. Okay, so for example, I'm a user and I'm using my mobile. Okay, so Google or Meta, they can show me the advertisement on my mobile. Okay, and it should be very fast, like less than 100 millisecond, otherwise I will scroll, right? And then money will get wasted, time will get wasted. Okay, so it should serve advertisement in less than 100 millisecond latency. Okay, then after that handle 10 million plus query per second reads. Why? Because see, if 10 millions of users are using that app, let's say, so all 10 million users, we have to show the advertisement, and our system will show the advertisement to them. Okay, our system will rank, we will have hundreds of millions of advertisement, and we need to rank them, okay, using the ranking services. We will be using here AI ML models, and then we will be finding the top candidates or advertisements, and then we'll show that to the user. And for each user you can show 3 to 5 advertisements. Okay, so 10 million plus query per second read would be required, because we have to serve that many requests. Now support real-time bidding or ranking. Let's say you have for me, okay, they will have three advertisers, and now they can show me they are competitors. So now I will find who is bidding more, okay, for to show the advertisement. So there will be a formula. Using that formula we will be selecting our candidate. Okay, so it should support real-time bidding plus ranking. After that, uses AI model for CTR CVR prediction. Okay, so CTR means click through rate. Okay, so CTR means like user will click that you're scrolling, let's say Meta, Facebook, and then you saw one ad. Okay, so user will click that ad or not, so that we will be finding CTR. Okay, and CVR is conversion rate, so after clicking on that, user is buying that product or not, so that is the conversion rate. So AI model will use the CTR CVR prediction. Okay, and then optimize for revenue, eCPM, UX, and fairness. So eCPM means our revenue. Okay, we are the advertisement services, so we will show the advertisement on these platforms. So eCPM, we will be getting value from money from advertiser. Okay, to display their advertisements. So eCPM we will calculate. We need to optimize it so that we will be getting the more profit. We will be using AI models for that. UX also, better UX. Okay, if you are showing one kind of advertisement to a user will get bored and he will log out from the system itself. So that should not happen. There should be some balance. Okay, we should show him different kinds of advertisements, and then fairness also. Okay, so for example, if Nike is paying you more, okay, the high businesses, if you just show their advertisement, then your then local businesses will get failed, right? So we need to make a balance so that there would be a trust. Now real-time example scenario, if you see here, so Rahul opens Instagram. Okay, and location, so Rahul's location is in Mumbai, and his interest is fitness, and he is using Instagram on mobile and at 8 p.m. Okay, night 8 p.m. So now your system must decide that which ad should I show Rahul right now. Okay, on the basis of that context. So serve ads in less than 100 millisecond latency. So latency is very important here. Okay, what it means, you must respond faster than user scroll, right? If user is scrolling, then to advertisement will waste and revenue will lost. Okay, you will not get any revenue from services. So Rahul opens app within 100 millisecond. Fetch user data. Okay, you need to find fetch user data, all this context that he's in Mumbai, he's using Instagram on mobile at 8 p.m. in the night. Okay, he will find the matching ad, we will rank them, and we show the best advertisement. to him. Now handle 10 million plus QPS. This is what I just talked about, that system must handle millions of users simultaneously. For example, during peak time, 10 million user open app every second, each needs advertisement, right? So your system must not crash and not slow down, because you have to cater these many advertisement to these many users. Now think, so here you can use distributed system, load balancing and caching. Now support real-time bidding plus ranking. So what it means? So multiple advertisement compete for Rahul's screen. Okay. So for example, three advertisers are there, like Nike, Puma, and local brand. So Nike is his advertisement is related to running shoes. For Puma, it is sneakers, and for local brands, it is gym. And these beat prices they are giving, like Nike is giving 50 rupees, and then Puma is giving 40 rupees. Local brand is giving 30 rupees. So here this is the auction, but you don't just pick highest bid. Okay, so like Nike is paying you 50 rupees, we don't pick that. We will go through one algorithm or one equation. Okay, so use AI model CTR CVR prediction. What it means, CTR means probability Rahul click that advertisement, CVR is probability Rahul buy that item. Okay, so for example, if Nike advertisement, he is giving you 50 rupees, okay, but his CTR is 2%, that user will click it or not. For Puma it is 5%, he is giving you lesser, like 40 rupees, local brand 30, and his click through rate is 6%. So if we find the score here, score equal to bid into CTR, so bid into CTR, you will find the score 1, 2 and 1.8. so here so who is the winner? Winner is Puma and not the highest bidder. See, Puma is giving you 40 rupees, okay, but the winner will be Puma because his score is more, right? So this is why AI is very critical here. Now optimize for revenue, eCPM, UX and fairness. So revenue is eCPM, okay. So formula is eCPM equal to bid into CTR into 1000. What it means? Higher eCPM, more money. eCPM means effective cost per mile, and how much revenue you earn per 100 ad impressions. Okay, sorry, 1000 ad impression. So how much ad revenue you are getting, that will we will be counting it as eCPM. Now user experience. So if Rahul sees irrelevant ad, okay, so he will get annoyed and he will leave the app. So show relevant ads only. So for that we will be using the user context, and according to his personalization we will be showing him the advertisement. Fairness, so you must be balanced between big advertisers like who's bidding high, and small advertiser, low bid but relevant. Okay, so for example, if always choose highest bid, then small businesses will die, right? So system adds quality score and uses exploration like bandit. What is that? Don't always show the best known ads, sometimes try new or less seen ads to learn if they might perform better. Okay, so in between just send this kind of just give chances to this kind of advertisement as well. Okay, so if I put all this together, so Rahul opens app, okay, system gets Rahul profile and contacts like he is in Mumbai and using Instagram on mobile. Then he will retrieve ads, okay, fitness related advertisements, and then AI predict CTR for each advertisement. Ranking, so he will find the score using bid into CTR, and auction will happen, so it will pick the top advertisements and then show best 2 or 3 advertisement, and then it will also log the impression and click. Impression means how many users you have shown that ad, okay, and click is how many user has clicked that app. So now scale assumption, if you see here, so daily active user is 1 billion, okay, for your system, and request per second, so peak request could be 10 million query per second. You will get advertisement inventory, you have 100 millions of advertisement, okay, and in that you have to select top 1000 to show it to user. Okay, advertisers, you have 10 millions of advertiser whose 100 millions of ads you have. Okay, so now average ads per request is 3 to 4 and latency budget is 100 milliseconds. So within 100 millisecond you have to show the advertisement. So internal breakdown, if you see here, for this 100 millisecond, so 20 millisecond will take your network, okay, retrieval will take 20 millisecond, retrieve the candidates, ranking will take 30 millisecond, and response will take 10 to 20 milliseconds. So it will be 100 millisecond. Now metrics explained, so I have explained everything here. Okay, let's check that. So daily active user 1 billion, meaning total unique user using platform per day. Okay, so example, Platform like Instagram, Facebook, so 1 billion user opens application daily. Now why it matters? Because see, massive scale distributed system is required, okay, and huge user data, so preference, history and behavior, you have to save all these things. You cannot store or process this in single database, okay, so distributed database should be there, sharding should be there. Request per second or peak request, if you see, so 10 million query per second, meaning at peak time 10 million advertisement request per second will come. Example, so you have 1 billion user per day, okay, so each opens application 10 times, let's say, so total request per day will be 10 billion, okay. And peak traffic, so evening spike, so 10 million requests per second, let's say, in evening after coming from office or from school or after completing the day task, user generally open Instagram, Facebook and all these things. So that time, so what is the spike, okay, that time evening spike we will be talking about. Okay, so now next is why it matters. So see, it requires load balancer because you have to serve so many requests, okay. It requires horizontal scaling and caching for the critical data. So even 1 millisecond delay will also cause your huge revenue loss, okay. So that's why. Now advertisement, just a minute. Okay, so now advertisement inventory, okay, so 100 million ads you have, and so meaning means total ads stored in the system is 100 million ads. For example, for Nike it is 1000 ads you have, okay. For Amazon you have millions of ads because Amazon will have lots of products. For each product you will have advertisement. Let's say one product is selling by different sellers, so different seller will create their own advertisement, right? So then small businesses also will have thousands of advertisements. So 100 million ads you have total advertisement inventory in for your system. Why it matters? You cannot scan 100 million advertisement per request, okay. Like one request is coming for Rahul, you have to show 3 or 4 advertisement. Now you cannot pick from all these 100 millions advertisements, okay. So you need a retrieval system, okay, which will filter 1000 advertisement for you. And then you need indexing as well, like search engine, okay. I have created search engine system design video, you can go and check there. So now advertisers, we have 10 millions of advertisers here, okay, so meaning number of business running ads. Example, big brand, startup or local shops. Why it matters? So see, multi-tenant system, so you will have one organization, and inside one organization you have multiple let's say tenants or multiple individuals, okay. So all these people will have different advertisement requests, okay. You have to cater that. Now budget tracking per advertiser. Now you can have each advertiser will have his own budget. For example, if it is Nike, then 10 lakh rupees per day they can spend. If he is a local individual, he can spend 500 rupees per day. So you need to take care his budget as well, so that your application should not exhaust their budget in few hours or few minutes itself. That should be balanced, so that for the entire day we can show their ad, okay. So fair auction system. Now here also introduces fraud detection and budget pacing. See, let's say if the competitors are there, okay, and they are clicking it using the bot, okay, so that the persons that advertisers daily limit for the price will get exhausted, right? So that kind of fraud detection we do, and budget pacing as well, okay. Means just make a balance between the for the budget, so that entire day we can serve their product advertisement. And now multi-tenant system, meaning one system serves many advertisers at the same time. For example, same system handle Nike campaign, small gym campaign and Amazon campaign, okay. So data must be isolated and secure. So you will have advertiser and we run campaign for them, where you will show their advertisement to users. Now budget tracking means each advertiser has money limit, okay. This is what I was talking about. For gym it is 500 rupees per day, for a startup it is 10,000 rupees per day, Nike it is 10 lakh rupees per day. So system must deduct money per click, per impression, stop ads when budget is over. If not, overcharged advertiser and legal issues will happen, right? So that will not look good. And fair auction system means you must balance big players like high budget things, and then small players low budget one. Okay, so just make a balance, show advertisement for both. So the problem here is, if system always pick highest bidder, then Nike will always win and small gym never show the ad. Okay, so the solution will be use quality score and bandit exploration. Bandit exploration means just show their ads, the small people's ad frequent, means occasionally. Okay, give chance to smaller advertisers as well. Fraud detection, so meaning prevent fake activities. Okay, so let's say someone clicks at ads 1,000 times using bot. Competitor tries to waste your budget, right? So system must detect fake clicks and suspicious patterns. Budget pacing, meaning spend budget evenly over time, not like in starting 5 minutes you have exhausted their complete budget. So example is gym has 500 rupees per day budget. Without pacing, 500 is spent in 1 hour, so rest of the day no ads. Okay, so with pacing, spend slowly across day and ads show all the day. So like 10 million advertisers means the system must handle millions of independent businesses, each with their own budget, campaign and fairness requirements. Okay, so now average ads per request 3 to 5, meaning for every user request show 3 to 5 ads, not much, not more. Okay, so for example, Rahul opens a feed, so one ad after every post, total 3 to 5 ads per session we can show. Why it matters? See, ranking must return top K ads, like K is 3 to 5. Okay, too many bids, so bad UX. Okay, he will see on the advertisement on his screen. Too few, so revenue loss, right? So balance is the key. Latency budget 100 millisecond, so means total time allowed to serve ad is 100 millisecond. Now breakdown. So network, this one we have already shown, right? For network 20, retrieval 20, ranking ML 30, auction 10 and response 20, so total 100 millisecond it will take. Now example flow, if you talk about, so Rahul open a app, so request hit server, fetch advertisement, run an ML model, rank and auction will happen, and then it will return you the ad all within 100 millisecond. Why it matters? See, hard real-time constraint forces in-memory system pre-computation and fast ML inference. Now connecting all metrics together. If you connect all the metrics, so let's combine everything in one request. Cannot scan 100 million ads. Okay, so you should have a filter there. Now must respond in 100 milliseconds, so you need to optimize the pipeline there. Happens 10 million times per second, so we need to scale it. Okay, and then must pick 3 to 5 advertisements, so you should be having the ranking critical system there. High level architecture, if you see here, so user client will be there. Okay, now it will show, we will cater the request from CDN, will show him the static content like images, JS, CSS. Okay, creative from edge locations instead of origin server, so it will be faster. Now it will go to API gateway. From API gateway it will go to different services, advertisement services like user context service, okay, which will handle the context of the user, ad retrieval service, feature store service. We are creating feature, okay, and then we are sending that feature to ranking system, machine learning ranking system, and then from there you will have an auction service, and each will have its own DB, right? And then you will get the advertisement response, top 3 to 5 advertisement you will get. Okay, so core flow, if you check here, so user open the application, request hits to advertisement server. Now it will fetch user profile and context, location, device, these all things. Okay, now retrieve candidate ads, so targeting match based on your geolocations, your edge, okay, and your interest. So now rank advertisement using ML, predict CTR, CBR, okay, then run auction, so compute eCPM, the formula is bid into CTR, run top advertisement and log impression or clicks. Now AI ML ranking logic, if you see here, so ranking formula is this one. So how you are finding the score, bid which they are offering, okay, then probability for the click, probability for the conversion, and then into quality score. So what feature we will be using from user point of view, we will check his age, gender, his interest. From context point of view, we will check the time when he is using the let's say Instagram, device and location. And for advertisement, we will check category, historical, CTR. Okay. Now here, which all ML models we will be using? We will be using logistic regression, deep neural network, and wide and deep model, 3 models. Okay. So here, this logistic regression is the baseline model. Means it's absolutely basic, simple and fast model used to predict CTR. Okay, click through rate, and means if we show this ad to user, what is the probability will click on that advertisement. Okay, works well with linear relationship between feature like user, advertisement, and context. Now highly scalable, commonly used in baseline in ad ranking system, basically we use. Now second is deep neural network, which is the advanced one, and here it will capture the complex and non-linear pattern, okay, in user behavior and advertisement interactions. Uses embeddings for user and advertisement, okay, better personalization. So we'll use embedding, we'll store it in a vector DB, we'll use it for the personalization, more accurate than logistic regression but higher latency and compute cost. So this one will be there, right? Wide and deep model, so this is industry standard model. Okay, so this is the combination of wide and deep. So what is wide? Memoization. Deep, generalization. Okay, so now here wide part learns frequent pattern like Nike sports user. Okay, so high CTR will be there. Now if then second is deep part, so it will learn unseen patterns. So what will come in unseen patterns? It will balance the accuracy and scalability. Okay, we use that in the Google ad system, this industry standard wide and deep model. Okay, now deep dive components. So here advertisement retrieval service, we have the first one. So what it will do, so let's say you have 100 million ads. Okay, quickly you need to find 1000 relevant ads for this. So this advertisement retrieval service will do that for you. And for real example, user Rahul opens the app, location is Mumbai, language is English, and interest is fitness. Okay, so here without retrieval if you go, so system will check all 100 million advertisement. It will take many seconds. Okay, it will take seconds. So you only have 100 milliseconds here. With retrieval, the system quickly filter advertisement targeting India or Mumbai, and then advertisement in English and advertisement related to fitness. So now 100 million will convert it to 1000 advertisement. It will filter. How does it do? So it will use inverted index. Okay, it will use inverted index, then targeting filters. So now what is there in inverted index? Like a search engine. Okay, so let's say here we will be using concept of Elasticsearch and Apache Solr. So what will happen, let's say instead of checking all the advertisement one by one, okay, we store, like for fitness we will be storing in 81, 87 and 80/20. Mumbai we are storing here, English we are storing here. So now Rahul system will find fitness advertisement, Mumbai advertisement and English advertisement, and whatever is the intersection. So here you can see 87, right? So common ads, so we will show that. So small set 1000, small set it will fetch, and then we will show that. Now targeting filters, if you see, so these are basic rule advertisers set. So for example, if it is geolocation is India only, if the language is English, if the interest is fitness, if the device is mobile, so that also filter we will be using. So what happens? So system removes advertisement that don't match Rahul's choices. Like US on the advertisement will not show him because he's from India. Spanish ad, cooking ad, okay, because his interest is in fitness. So on the relevant advertisement remain. Why use Elasticsearch or Solr here? So because they are super fast search engines built for filtering and indexing, okay, and then can handle millions of records. Now final simple flow, if you check here, so user request come, apply filter, okay, based on his geo, language and interest, and then use index to page matching advertisement. So reduce 100 million to 1000 ads. Feature store, what all features we will be using? So we will be using user feature, advertisement feature and real-time signals. So these features are nothing. You get the raw data and then you extract feature from that, and then you send this feature to machine learning model. So whatever machine learning model required, you just extract that from the raw data, and we called it as feature. We store it in a feature store. So tag here, we will be using Redis, okay, for the hot features like you're using frequently, and Apache Cassandra for the long-term features. Now ranking model, okay, so load ML model in memory and batch scoring of candidate. So ranking will give the ranks, okay, to the candidates. Candidates is your advertisements. So latency critical, so must proceed 1000 advertisement in less than 20 millisecond. Auction service, if you check here, so second price auction, okay, you see everybody is placing a bid, but we will not pick the highest bid, we will take the second highest bid. Why? See, winner pays price which is of the second highest bid, okay. Now ensure, this one will ensure fairness and revenue optimization. So what is second price auction? See, winner is decided by the highest score, but winner does not pay their own bid, okay. Instead winner pays based on the second best competitor. So for example, Nike, he is giving you 50 rupees to show his ad, okay, but his CTR is 2%, so score will be bid into CTR will be 1. Same for Puma, it is 2, and for local it is 1.8. So who's the winner here? The winner is Puma, right? So highest score Puma 2 is the highest here, okay. So Puma is winner. So how much he should bid? He should bid 40 rupees, but he will not give you 40 rupees, okay. If you wanted to decide price, okay, so formula will be second highest score divided by winner CTR. So here second highest score is 1.8, okay, and winner CTR is 5%. So Puma's CTR is 5% and second highest is 1.8, okay. So 1.8 divided by 5%. So it will be somewhere around 36 and not the 40, okay, because see, if you see, Puma will give you 40 rupees, but we are asking only 36 rupees, so we are maintaining trust there, okay. So final result, Puma wins and Puma will pay 36 rupees and not 40 rupees. Why not pay 40 rupees? So because system says you only need to bid the second best competitor and not pay your full bid. Why this is very powerful? See, advertisers don't overpay. So Puma was ready to pay 40 rupees, but he is now needed to pay 36 rupees. So this one will build trust in the system. Now, database design, if you see here, okay, we have few tables like advertiser table, okay, which will have the advertiser ID for which you are running the advertisement, okay. Then the name, budget, what is their budget for per day, balance, and then created ad. Now campaign table, so you are creating one campaign, you will create one campaign for the your advertiser, okay. So you will have some campaign ID, advertiser ID, okay. Now you can run that campaign for multiple advertisers, so you will have advertiser ID there. Then daily budget, for every one it will be different, start date, end date, and then status. Third table will be advertisement table, so here you will be having advertisement ID, campaign ID, okay, and then because that advertisement will run under some campaign. Creative URL is your actual content, advertisement content, okay, like your image, video, and then bid, how much bid they are giving you, and then targeting is who should see this ad, okay, the genre. Then status. Then you have impression table, okay, so right heavy. So impression will be right heavy. Why? Because here we are let's say you have 10 billions of users, so you're showing advertisement to 10 billions of users, and also you're tracking that impression also, impression or click, that who to whom we have showed this and who has clicked on it, okay. That's why it is right heavy, and we will be using here Apache Cassandra, because Apache Cassandra you use for the high write throughput, okay. So here you will have impression ID, advertisement ID, of course impression will be related to one advertisement only, right. User ID to whom you showed it, and then timestamp, and then here you will be using clustering order by timestamp, okay. So why is this the right heavy? Because you have millions of users and each sees multiple ads. Now example, like you have 10 million users and each sees 3 ads, so you will have to get like 30 million impression per second. You have to show this. System must handle huge number of writes and very fast ingestions. Why use clustering order by timestamp VSC? So means store data sorted by the latest time first. Why needed? When you query show recent impression of user X, so you instantly get the latest record first. Okay, you don't need to sort it then later. Now click table, so who has clicked it, so that information will store here. So click ID, advertisement ID, user ID and timestamp will be here. Now if we talk about here Java low level LLD design, so first you will have, we have multiple models, we have multiple classes here. Okay, so for example, first one is advertisement request. Okay, so you will have here user ID, location. Okay, user's location, because user is using his Instagram on the mobile, let's say, the device type. Okay, and then you will have a map of context. Okay, string comma is a string. So we'll see the example for this. Okay, so what it is, represent what we know about user at the request time. So here you will have user ID Rahul, location Mumbai, device mobile, and the context is like time 8 p.m, app is Instagram, and interest is fitness. So this information will come here. Now advertisement add candidate. Second model you will have add candidate. So it will have advertisement ID, bid ID, and then map of feature. Okay, so advertisement that passed filtering. Retrieval stage. Okay, so for example 100 million we are filtering 1000 candidates. Okay, so for example advertisement ID is 101, bid is 50 rupees, feature, what will be the feature here? Category fitness, historical CTR is 0.04, and quality score is 0.8. Now ranked advertisement. So ranked advertisement, what it will come, so like advertisement ID and score. Okay, so now here what it is, advertisement after ML scoring. For example, advertisement ID is 101 and score is 201. So ranking service, now we have services here. Okay, so first one is ranking service. So ranking service will have the function rank. Okay, it will find the, it will give the rank to each candidate. So it will definitely take a list of candidate and user to whom we are serving this candidate. Okay, and then what it will return, it will return you list of rank advertisement. So now here first you will create the list of result of type ranked advertisement, and then you will iterate that candidates what you are getting. Okay, you're finding it's you're predicting it's a CTR, and then you're finding it's a score. Okay, with the formula bid into CTR. So now you're adding that into the result, and then you're sorting that result and returning that list. Okay, and then predict CTR, what it will be, some ML model inference will be there, but right now it is hard coded as dummy value 0.05. Second is your advertisement service. Okay, serving service. So here you will have a retrieval service and ranking service. Okay, now here it will serve the ad, so it will take the advertisement request and will send you the list of advertisement. Okay, so here first you will fetch the candidate. After fetching, you will rank those candidates, and then you will select top advertisement and return that list. Scaling strategy here, if you talk about, so see, if you need to scale your application, okay, for reading, so in that case we will use a stateless service horizontal scaling. Okay, so you will create a multiple servers here, and also it is a stateless, means we are keeping session detail in let's say Redis server. Okay, global server, and then load balance you can use, balancing you can use. Now right scaling, if you need to do right scaling for your application, so we will use Kafka pipeline. Okay, Apache Kafka for logs. Now caching we will be using for hot advertisement, which we need to show to each user. We will be storing that in Redis, and for user profile we will cache that. Okay, now sharding, so we will shard basis of region and category. Pre-computation, so CTR and user embeddings we can pre-compute so that our system will be faster. Now advanced topic, if we talk about here, so real-time feedback loop. Okay, so if you click, if user is clicking, so we will update model in real time only, that time only. Okay, near real-time training. The cold start problem, so if there is a new advertisement, okay, we don't have any data for it. Okay, it's a CTR, historical data. So in that case we will be using exploration strategy, means we will be occasionally we will show this kind of advertisement to user one by one, so that we will capture some data. What is cold start problem? So new advertisement have no data, no CTR, no history, so system doesn't know how good they are. Why it happens? Because ranking depends on score. Okay, bid into CTR, the formula, but you don't have the value of CTR, that's why. Now solution exploration strategy. Okay, sometimes show new advertisement even if you are not sure about them. Fraud detection, so how you will manage the fraud here. So you will detect the fake clicks, and use anomaly detection models. Budget pacing, so ensure budget lasts whole day, okay, and not in initial 1 hour, it will get exhausted. A/B testing, so experiment ranking models, okay, like for 20% you show result from different model, and for 80% show from different model, and then track the metrics from both. Now if you talk about here bottlenecks and solutions, so here see, high latency is the bottleneck, okay, so for that you will be using caching and pre-ranking. ML slow, so model optimization you need to do. Data skew, like only one advertisement is showing to whole user, so in that case you just use sharding, okay, just divide that. Hot users, so cache that user. So what is data skew? Uneven distribution of data or traffic across system nodes. Simple example, you have 3 servers, so server A is getting 80% of traffic, B and C is getting 10, so data is skewed here for server A. Final architecture summary, if you talk about here, so see, for retrieval we will be using filter advertisement. For ranking we will be using ML scoring. For auction we will be using price decision, okay. For logging we will be using feedback loop, and we will be train the model, and then for training we will be using continuous improvement. So that's it.